Black holes are among the most mysterious objects in the universe. Imagine a region in space where gravity is so strong that nothing, not even light, can escape. This is a black hole. They pull in everything that comes too close, swallowing stars and even entire galaxies. Many black holes are born from the death of massive stars. When these stars run out of fuel, they collapse under their own gravity, creating a black hole. This collapse can release energy that outshines an entire galaxy for a brief period. The result is an object with a gravitational pull so strong that it warps space and time around it. When they merge, the event sends ripples through space-time, known as gravitational waves. These waves travel across the universe and can be detected by special instruments on Earth. Understanding black holes helps us understand the very fabric of our cosmos. Black holes begin their life as massive stars. These stars live for millions or even billions of years, burning through their nuclear fuel. When a star exhausts its fuel, it can no longer support itself against the force of gravity. The core collapses, resulting in a supernova explosion. This explosion blows off the outer layers of the star, leaving behind a dense core. If the core is heavy enough, it will continue to collapse under its own gravity. This collapsing core becomes a black hole. The process is quick, taking only a few seconds. During this time, the density of the core increases to unimaginable levels. The gravity becomes so strong that even light cannot escape, and a black hole is born. Thus, while black holes signify the death of a star, they also play a crucial role in the cycle of cosmic evolution. The event horizon is a defining feature of black holes. It is the boundary beyond which nothing can return. Once an object crosses this line, it is doomed to be pulled into the black hole's core. This point of no return is why the event horizon is so fascinating and terrifying. The event horizon is not a physical surface but a region in space. Think of it as an invisible sphere around the black hole. Its size depends on the mass of the black hole. The more massive the black hole, the larger the event horizon. Once something crosses the event horizon, it cannot escape. This includes light, which is why black holes appear black. The gravity inside the event horizon is so strong that it bends light back towards the black hole. The event horizon is a crucial concept in understanding black holes. Imagine falling into a black hole. As you get closer, the gravitational pull becomes stronger. Time starts to slow down relative to the outside world. This effect is known as time dilation. From an outside observer's perspective, you seem to freeze at the event horizon. But for you, time continues normally, and you cross the event horizon without noticing anything unusual. Once inside, things change dramatically. The gravitational forces become overwhelming. These forces stretch and squeeze objects in a process known as spaghettification. If you were to fall feet first into a black hole, your feet would experience a stronger pull than your head. Crossing the event horizon is a one-way journey. The singularity lies at the heart of a black hole. It is a point where matter is crushed to infinite density. This concept is difficult to grasp because it defies our everyday experience. In the singularity, the gravitational forces are so strong that they warp space and time beyond recognition. The laws of physics as we know them no longer apply. Einstein's theory of general relativity predicts the existence of singularities. However, the theory breaks down under these extreme conditions. This is because general relativity does not account for quantum effects. To fully understand singularities, we need a theory of quantum gravity. This is a major goal in modern physics, but such a theory remains elusive. The singularity represents a boundary in our understanding. It is a place where our current theories cannot explain what happens. One of the most mind-bending aspects of black holes is time dilation. This phenomenon occurs because of the intense gravity near a black hole. According to Einstein's theory of general relativity, gravity affects the flow of time. The stronger the gravitational field, the slower time passes. Near a black hole, gravity is so strong that time can slow down significantly. Imagine a clock near a black hole and another far away from it. The clock near the black hole would tick slower than the one farther away. This effect becomes more pronounced the closer you get to the event horizon. If you were to hover just outside the event horizon, time for you would slow down dramatically compared to someone far away. This time dilation has fascinating implications. In theory, you could travel into the future by spending time near a black hole. In 1974, physicist Stephen Hawking made a groundbreaking discovery. He proposed that black holes are not entirely black. Instead, they emit a faint radiation. This radiation arises from quantum effects near the event horizon. Empty space is not truly empty. It is filled with virtual particles that constantly pop in and out of existence. Near the event horizon, these virtual particles can become real. One other escapes. The escaping particle takes energy away from the black hole, causing it to lose mass. Over time, this process can lead to the black hole evaporating completely. Suggested that black holes are not eternal. Hawking's discovery has opened up new avenues of exploration and challenged our understanding of the universe. Black holes are not just isolated objects. They play a crucial role in the formation and evolution of galaxies. At the center of most galaxies, including our Milky Way, lies a supermassive black hole. These black holes have masses ranging from millions to billions of times that of our Sun. They influence the behavior of stars, gas, and dust in their vicinity. The presence of a supermassive black hole affects the dynamics of its host galaxy. It can regulate star formation and shape the galaxy's structure. When matter falls into a supermassive black hole, it forms an accretion disk. This disk heats up and emits powerful radiation, creating what we call an active galactic nucleus, or AGN. AGNs can outshine entire galaxies and are among the most energetic phenomena in the universe. The interplay between supermassive black holes and their host galaxies is a key area of research in astrophysics. It helps us understand how galaxies form and evolve over cosmic time. While we know a lot about stellar mass and supermassive black holes, there is a middle ground that remains elusive. These are the intermediate mass black holes, with masses between 100 and 100,000 times that of our Sun. Their existence is still debated, and finding them is a significant challenge. Scientists believe they could form from the merger of smaller black holes, or the collapse of massive stars. Intermediate mass black holes could provide crucial insights into the growth of supermassive black holes. They might serve as building blocks merging over time to form the giants we see at the centers of galaxies. However, detecting them is difficult because they do not emit much radiation and are often hidden within dense star clusters. Several candidates for intermediate mass black holes have been identified. Despite these efforts, confirming their existence remains a top priority in astrophysics. Black holes have captured the imagination of the public and have become a staple in popular culture. They appear in movies, books, and even music. Their mysterious nature and immense power make them perfect subjects for science fiction. One of the most famous depictions of black holes is in the movie Interstellar, which explores the effects of time dilation and the journey into a black hole. In literature, black holes often symbolize the unknown or the ultimate challenge. They represent a boundary that characters must cross, often at great risk. This symbolism resonates with our fears and curiosities about the universe. Black holes also appear in video games, where they serve as obstacles or portals to other dimensions. The fascination with black holes extends to art and music. Artists create stunning visual representations, capturing the beauty and terror of these cosmic objects. Popular culture helps bring the science of black holes to a broader audience. Black holes are among the most studied objects in astrophysics, yet many questions remain unanswered. One of the biggest mysteries is the nature of the singularity. What happens to matter and information that falls into a black hole? Theories like the holographic principle suggest that information is not lost but encoded on the event horizon. Another area of research is the role of black holes in galaxy formation. How do supermassive black holes grow so quickly in the early universe? Studying ancient galaxies and their black holes can provide clues. The detection of gravitational waves from black hole mergers has opened up a new way to study these objects. Future observatories will help us detect more events and understand the properties of black holes better. The search for intermediate mass black holes continues. Finding them will help us understand the full range of black hole sizes and their formation processes. The mysteries of black holes remind us that the universe is full of wonders waiting to be discovered.